Hi, so the question has come up. I'm having trouble with imaginary numbers, and I wanted to take a few minutes and review it, both for the take home test and for the final. And so, what is an imaginary number? Well, there's real numbers and imaginary. Real numbers are things you can do operations on in your calculator. So, if you tried to type the square root of 16 in your calculator, you would get 4. If you type the square root of 2 in your calculator, you would get 1.414 and a bunch of other numbers. But if you type in your calculator the square root of negative 16, you will get an error because you can't take the square root of a negative number using real numbers, and calculators work with real numbers. So what you do is you break it into parts, and that's going to give you an imaginary part. So I'm factoring the 16. I'm making it be negative 16, I'm sorry. You make it be negative 1 times the square root of negative 1 times the square root of 16. And we've defined this term right here to be I. And so we're going to make that, sorry, I do it every time. We're going to make that become I. And then the square root of 16 is just 4. And so we would typically write that as 4 times I. And so that's how you get an imaginary number. We're defining that square root of negative 1 as the part with an I. We use them mostly when we're finding roots of things or solutions. And we use them in quadratic equations, and we're going to use them again, and the reason I'm stressing it now, or polynomial equations, which are coming in our next chapter. So I want to make sure you're really comfortable with this before we move on to the other stuff. And so let's just talk about how to simplify a fraction with an imaginary number. So let's say I take the square root of negative 50. What you're going to do is you're going to look for ways to take perfect squares out of that. So perfect squares are things like 1 times 1 is 1, 2 times 2 is 4, 9, 16, 25, 36, 49, 64, etc. And so what we're going to do is break this into parts. And so we're basically factoring it. I don't know if you remember when you were littler, you broke things into like 25 and 2. Do you see that that has a perfect square, because it's on our perfect square list, and a not perfect square part? So you're looking for opportunities to take that out. In addition, there's that negative there. So we're going to break this into parts. Factors that combine to be the square root of negative 50. So the square root of negative 1 needs to be there. The square root of 25 is the perfect square part. So let's break this down. This is the perfect square part. This one here is a not perfect square. And then this is the part that's going to get us our imaginary piece. And so we're going to say this is I times the square root of 25. Because it's 5 times 5 is 25, the square root of 25 is 5. And then the square root of 2 doesn't have a perfect square, so it stays inside the radical. So that this is right. The typical best way to write it would be to go 5i square root of 2. And that's what happens when it doesn't simplify completely. There are times where it just becomes an I term. So for example, if I take the square root of one of these perfect squares, like this, right? We know that 49 is just 7 times 7, but now we're going to break it into that imaginary piece and the perfect square piece, and there's no non-perfect square part to this. So then we're just going to simplify each part. And so that's going to become 7, or I times 7, which we would probably write as 7i. So I hope that helps with manipulating those radical pieces at the end. So the next question becomes, so when do we use them? Well, I said we use them to find solutions or roots to quadratic equations. Well, here's a quadratic equation. Right now, remember, we have to have it set equal to 0, and it is. And so then we're going to use the quadratic formula. We're going to identify A, B, and C, A is 5, B is 6, and C is 4. And then I find the discriminant. So the discriminant is b squared minus 4ac. So that's going to be, and that's that part in the square root of the quadratic formula. And so I'm going to go in and say that would be 6 squared minus 4 times 5 times 4. And so it's going to be, sorry, I should have done that as well, 36 minus 100, and that's going to equal negative 64. And so if you remember the quadratic formula, x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. That this part right here is the part that goes in here. And because it's negative, you're going to get two imaginary solutions. You're going to get imaginary solutions because it's negative, and you're going to get 2 because you have a plus or minus in front of it. And so let's go ahead and substitute in now. So we're going to go x is equal to negative b is 6 plus or minus the square root of negative 64 divided by 2 times 5. And x could equal negative 6 plus or minus the square root part here. Remember, I'm going to step aside and do some calculation on this so it's going to be, well, what is the square root of negative 64? Well, it's the square root of negative 1, and 64 is a perfect square. So that's going to allow me to just write it as I and 8, and we're going to write that as 8i. So that would be plus or minus 8i, and that's where that came from. And then we're going to divide by 10. That is a correct answer. It would be better if you simplified it. In order to simplify it, I'd probably take it and go negative 6/10 plus or minus 8i over 10. And then what happens is you can simplify these fractions like you would before. And so this would be negative 3/5 plus or minus, and then you'd probably write it as 4/5 I. That gives you kind of a coefficient in front of your I. You could have simplified it back here as long as you recognize that all of these are even, and you have to take a 2 out of all of them. You can't just take it out of part of it. And so I would have accepted negative 3 plus or minus 4i all over 5 as well. These two answers mean the same thing. And so that would be a way to do it. So let's do a couple more just to make sure you're getting the gist of it. So that it would be a is equal to 2, b is equal to negative 2, and c is equal to 1. So we're going to go and check our discriminant. B squared minus 4ac, that's that part inside the square root. And it would be negative 2 squared plus or minus, oh, not a minus, I'm sorry. Got my parts of the formula. Minus 4ac, thanks, 4 times a times c, and that's going to get us 4 minus 4 times 2 is 8 times 1, and we're going to get negative 4. So once again, we're going to get two solutions because it's going to be the plus or minus, and they're going to be imaginary because that discriminant is negative. So then we're just going to plug it back in. X is equal to negative b plus or minus the square root of our discriminant, all divided by 2 times a, and that's going to get us the opposite of negative 2 is 2, plus or minus, let's do that thinking step again. We're going to step out here and say, what is the square root of negative 4? Well, it's the square root of negative 1 times the square root of 4, and that's going to get us I and 2, so we're going to write it as 2i, so it's going to be plus or minus 2i, all divided by 4. And so that would be correct. The better solution might be 2 fourths plus or minus 2 fourths I, which we would simplify to be 1/2 plus or minus 1/2 I. Sometimes you choose to leave it as this fraction, and that would become 1 plus or minus I all over 2 if you simplified it. So these two things actually mean the same thing. So if you think about that, it's just combining like terms, or in our case, distributing them. So let's do one more. If you notice this one, you'll notice it's not set equal to 0. So that's going to be our first step, is we're going to move these to the other side. Oh, I did that wrong too. It's early. Sorry, guys. So we're going to add 7 to both sides. I'm trying to do too much at once. Add 7, and we're going to get 2x squared minus 6x plus 7 is equal to 0. And then we're going to go, well, what's my discriminant? Oh, I need to identify my A equals 2, B equals -6, and C equals 7. So I'm going to go, that's -6 squared minus 4 times 2 times 7. That's going to give me 36 minus 8 times that is 56. It's going to equal -20. So once again, because of the plus or minus in the discriminant, in the quadratic formula, you're going to see there are two solutions, and because it's negative, they're going to be imaginary. So now let's substitute that. I'm going to move this out of my way, actually, so that I can continue with the quadratic formula. So I'm going to go, well, that would be x is equal to the opposite, -b, plus or minus the square root of -20, all divided by 2 times the a value. And so the opposite of -6 is 6, plus or minus the square root of -20. So let's do that thinking part. Let's go, well, the square root of -20, can't put your negative there, it's inside. -20 is -1. The perfect square that would divide out of that is 4. And then there's a non-perfect square part. So this one's going to have a radical left in its answer. And so that's going to become I, that's going to become 2, that's going to become the square root of 5. And so you'd probably see that answer as 2I root 5. And so that's what I'm going to put down here is 2I root 5. So I do my calculations kind of on the side, and then I'm going to divide by 4. Right, but it gets simpler. 6 divided by 4. I'm not sure it's simpler, but it certainly is a different way to look at it. Square root of 5, I, and so that would be 3/2 plus or minus. You'll see these simplify as 1 and 2, so that would become the square root of 5 over 2 and I. And so at this point, you'll see that this is a solution, so is this. It's that kind of thing. And so that's the kind of thing you're going to work through when you're working with imaginary numbers. So there's one last thing about imaginary numbers that I want to make sure we talk about, because I know there's one question on the final about it, which is how do we rationalize, or looks like a dividing problem. The rule says no i's in the denominator. You're not supposed to have radicals in the denominator, and technically an I is a radical. So no i's in the radical or in the denominator. And so to do that, we're going to find what's called its conjugate. And all that is the conjugate of the denominator is the same numbers, but the opposite sign. And so that's a negative. We're going to make our conjugate positive. And we're going to multiply our problem up and down, because we're creating an equivalent fraction, times 5 plus 7i over that. And so if you think about what that means, it means we're really just multiplying by 1. The ugliest one ever, but we're multiplying by 1. And so now what I like to do, I'm actually going to shift this down. I like to do the denominators separately from the numerators. And so I'm going to do my denominators first. So when I distribute these, I'm going to distribute 5 to 5, and that's going to get me 25. And then I'm going to distribute 5 to 7i and get 35i. And then I'm going to distribute negative 7i to 5 and get negative 35i. And I'm going to distribute negative 7 to negative 7i to positive 7i, and I'm going to get negative 49i squared. And so when we're working with these, you'll notice, because you chose the conjugate, these are always going to cancel out. And then you may not recall, but back before Thanksgiving, we figured out that I squared equals negative 1, because the square root of negative 1 squared, which is what I was, is just equal to what's inside the radical. And so that's why we do that. So we're going to replace 25 minus 49, but I squared is negative 1. And so we're going to say that becomes 25 plus 49, and that's going to be 60 plus 14 is 74, I believe. And so it's going to be, that's going to be your denominator. So all that messy denominator becomes the number 74. So I'm going to just jot that down here from, oh, sorry, my stuff switched here. Now I'm going to do the same kind of math in the numerator. So I'm going to multiply my first two terms, and that's going to get me 10. I'm going to multiply my two terms here and get plus 14i. And then I'm going to multiply these two and get plus 15i. And then I'm going to multiply these two and get plus 21i squared. And so you're going to notice this time your i's don't cancel out, but you are not allowed to have a square in the denominator. So that's another one of those rules. No exponents on I. There's a lot of rules about silly stuff, but that's okay. So we're going to go back in here, and I'm going to start doing some things. Combine like terms. This becomes 29i, but this part becomes 21 times negative 1, because I squared is negative 1, just like we showed before. So it's going to become, I'm working up this way so that it just worked that way. So this is going to become minus 21, 10, 29i, and that's going to become negative 11 plus 29i. So sometimes you'll see it written as this kind of fraction like this. It's okay to have i's in the numerator. It's only the denominator where you're not allowed to have i's. The next step might be to write it as a complex number. So it would be negative 11 over 74 plus 29i over 74. So that's how you do dividing with imaginary numbers. And so that's kind of, this one is an answer. This is 2. It just depends on who wrote the textbook or who wrote the test. And so it's that kind of thing. So I hope that helps. If you have questions, I'm in office hours every day at 1:15 up through till our final day. And so I hope that helps. Thanks. Bye.